Now our last video ended with the sequence 1 over n factorial, and it didn't present itself in a way that would be obvious as to what a factorial is. The sequence we were looking at, if you'll remember, was 1 over 1, 1 over 2, 1 over 6, 1 over 24, and then we just let that trail off. And those values in the denominator, 1, 2, 6, 24, the next one would be 120. Those are different values of a factorial. And what a factorial is something that comes up shockingly frequently in mathematics. What it is a shorthand for taking a positive integer, like 1, 2, 3, 4, 5, 6, 7, and whatever that number is, we want to multiply it by all the positive integers that are less than or equal to it. So for example, 7 factorial would be a shorthand for 7 times 6 times 5 times 4 times 3 times 2 times 1. But that takes a lot of writing. And so instead of writing all of that out, I'll just write 7 exclamation mark, pronounced 7 factorial, to abbreviate this big long thing that we have right here. So if I were talking about 1 factorial, it's somewhat vacuous. I want to take 1 and multiply it by all the positive integers less than or equal to it. There's nothing to really multiply. So 1 factorial is just 1 multiplied by itself. That's 1. 2 factorial would be 2 multiplied by 1, and that just happens to be 2. Things start to get interesting at 3 factorial. What we're looking at there is 3 times 2 times 1, which happens to be 6. And 4 factorial would be 4 times 3 times 2 times 1, or 4 times 6, which is 24. So those values we were seeing at the previous page are 2 times 1, 3 times 2 times 1, 4 times 3 times 2 times 1, and so on. So those first handful of values for factorials, they come up so frequently, they're worth memorizing and recognizing that pattern. They'll come up for us a lot in our work with sequences and series. So it's good to get a feel for what those are, but that's all that's meant when we see this factorial right here. But it brings us to our next point. In that example 6, I simplified all the arithmetic, 2, 6, 24. The pattern would have been a lot easier to see if I had written it as 1, 2 times 1, 3 times 2 times 1, 4 times 3 times 2 times 1. That pattern would have been easier for me to see. You'll also notice that in sequence 5 on the previous slide, I could have just done this subtraction, 2 minus 1, and written 1 here. I could have done this addition, 2 minus a third. I could have done all of that simplifying, but it wouldn't have actually made the pattern easier to see. In general, when you simplify, when you're working with sequences and series, what you're doing is hiding a pattern. When you don't simplify, you're making the pattern easier to see. And so I'm therefore granting you permission on this first day of calculus to basically never simplify, or to simplify very little. In fact, in not simplifying, I think you're making it simpler for me and yourself to understand what's going on. And so that'll be a big trend for us as we're working in calculus, is to not simplify expressions in order to better see patterns. So permission granted, you've graduated, you're at the next level of mathematics. You don't have to waste your time simplifying things algebraically any longer. Now, the very next topic we're going to get into regarding sequences of numbers are convergent sequences and divergent sequences. Recall that we're really only interested in sequences of numbers that have a very predictable pattern. There's one step further in terms of level of interest for us. We will often only be interested in sequences that converge. And let's start with a loose definition of convergence, which is a sequence converges if it's approaching a particular value. It's heading toward this one number. Each term in the sequence gets us closer and closer to that number. A divergent sequence, or a sequence that diverges, is one that doesn't do that. And we'll explore those ideas of convergence and divergence more closely in some of the next videos. But for now, I want us to stick with that loose idea. Convergent means the values are approaching something, and divergent means that they're not approaching something. And I want us to look at those same 6 sequences that we started with. So again, I'm going to ask you to pause the video, and for each sequence here, think about, do you think this sequence approaches something? And if so, what is it approaching? Or do you think this sequence doesn't approach anything? It's not heading towards any one number in particular. So pause the video, come up with an answer of convergent or divergent for each sequence that we have here, and once you've done that, move on to the next video.